Okay, so in this video, I want you to take a minute. This is, if we were in class, this is what you would be doing, is I would ask you to complete the warm-up on your own to try to see the pattern. So basically, you're going to look at these numbers, and we're going to talk about zero and negative exponents, and we're just going to kind of go through what we already know about what exponents mean. So take a minute, pause the video where it is, if you want to do it like we would do it in class, and go through the 3 questions on the bottom and see if you can figure out the pattern that happens as exponents decrease. Okay, so if you went through, there are some things you could have answered. So exponents they mean repeated multiplication. And the more you go up, the more the exponents increase, the larger the number gets. So for example, if you had 4 to the first and you wanted to go to 4 to the second, you would just multiply it by 4. So if you notice, if you go this way, your products actually multiply by 4 as you increase, right? So that's one pattern that you could have seen. You could have also seen as you go down, you divided by 4. If you divide each product by 4, you'll get to the one below. So that is really important. So as exponents decrease, divide by base. So if you remember from kind of our units from before, or our lessons from before, our base is the number that's next to the exponent. So you're just dividing by that number every time, or increasing. Okay, so that's kind of, this last question kind of goes with that question, so I'm not going to write more. So that's kind of the basis. That's a pattern that we need to know for today. And so we're just going to kind of extend it for a minute. So if we look at the same picture here and we think, okay, what happens if we continue the pattern? What would 4 to the 0 be, right? My exponents decrease. I talked about each time I divide by 4. 256 divided by 4 is 64. 64 divided by 4 is 16. 16 divided by 4 is 4. And so what if I did 4 divided by 4? What would that get me? Well, that would get me 1. Okay, so 4 to the 0 would equal 1. Okay, so let's prove that using expansion. So we're going to first prove that this is true. And so to do that, I'm going to use expansion. So I'm going to expand the top just like we were doing the past couple days, and expand the bottom, and then simplify and see what I get. So if I do this, I have 5 7s, and then I divide by 2 7s, and if I divide them out, I get 7 to the 3rd. Then I asked, what can I do with the exponents to simplify without expanding? So what's the pattern here? What do I really do with my exponents to simplify them? Well, if you notice, 5 minus 2 is actually 3, so you can actually just subtract exponents. Okay, so that's kind of like the quotient rule. We don't really talk about rules, but when you expand them, that is the shortcut way. Expansion is always a way to ensure you're right and to prove answers, but subtracting is kind of like the trick. So now using that idea, let's kind of prove that a to the 0, which means a could be any number, is equal to 1 using the quotient rule. So let's expand and simplify 10 to the 3rd over 10 to the 3rd. So if we subtracted these exponents and took the shortcut, we would get 10 to the 0, right? And so if I expand them out, if you look, all of these divide out, which means 10 divided by 10 is equal to 1. But we also said this is also equal to 10 to the 0. So this is why when you divide or when you have an exponent to the 0 power, it is equal to 1. Because you're really saying you have the same amount of bases on the top as you do the bottom, and when you divide a number by itself, you get 1. So that means no matter what number I have, if I use 10, if I use 7, if I use a for any number, anything to the 0 power is 1. Okay, so x to the 0 is 1. Okay, so that is kind of a little bit about 0 exponents. So if you flip, now I want to kind of talk about negative exponents, right? So again, let's kind of use this picture to kind of show us a pattern here. So 6 to the third is 216. 6 to the second is 36. So if you look, the pattern would be divided by 6 because that's my base. And I can just do the math to show that. Again, we showed anything to the 0 power is 1. So again, if I divide by 6, I get 1, which continued my pattern. But if I do that again, if I continue this pattern to decrease and I get 6 to the negative 1, and I divide by 6, I'd get 1/6 if I kept it as a fraction, right? Or 0.16 repeating, right? So that's kind of interesting. If I divided by 6 again, maybe to figure out what 6 to the negative 2 was, I would divide by 6 again. So if you do in your calculator 1/6 divided by 6, and you turn that into a fraction, you get 1/36, which if I wanted to write this number with exponents, it's really saying 1/6 squared. So this is saying that these two things are equivalent. Okay, so if we continue the pattern, we said that 6 to the negative 1 would be equal to 1/6, right? What about 6 to the negative 2? Well, we said that would be equal to 1/36, because all you're doing is taking what we had before and dividing it by 6, which is also the same as 1/6 squared. So these are kind of all equal to each other. They're all the same because I'm continuing that pattern of dividing by 6. Okay, and so that kind of answers that up there. We'll kind of keep that. So what if I wanted to write 8 to the negative third using a positive exponent? So a lot of times when you have negative exponents, they're going to want you to change to positive. So what I would do, because 6 to the negative 2 is the same as 1/6 squared, I'm going to take my exponent and pretty much move it to my denominator. So and if you notice what my number was up top was 1. And if you don't see 1 in this, but it's actually just the coefficient there. So it's really like I took the coefficient and moved the base over or under the fraction. So 8 to the negative third, my coefficient again here is 1. So I'd have 1 over, and then 8 to the negative third is the same thing as dividing by 8 to the third. So this 8 to the negative third is equal to this, which we could also write as 1 over, and we could actually do 8 to the third, and that would be 512. So those are all equivalent statements. This is how you would write a negative exponent as a positive one. So if you notice, just because your exponent's negative doesn't mean you have a negative number. It just means that you move your exponent. So none of these negative exponents will ever give you a negative number because you're just dividing by your base more, if that makes sense. So if you flip the page, that's really all the notes, and then we're just going to kind of look at different types of examples. So this first part of the practice, it just wants you to order your exponents. So if you do 2 squared, right, you get 4. Where does 4 fall on your number line? Well, it falls right here. So this would be where 2 squared falls, right on 4, right? And so you can use your calculator with this. Where does 9 to the 0 fall? So kind of label these on your number line to kind of see where they go. Okay, so that's just that first part. Do it with each one of those. And then the next part is just simplifying each of the exponential expressions using only positive exponents, right? So a couple of these are easy, right? And we said anything to the 0 power is 1. We proved that. Okay, and then anything negative we can kind of turn positive. So for example, if we talk about number 1, 8 is raised to the 0 power. So that would be equal to 8, right? Slide over to number 4. 4 is a little different because I'm not just doing 5 to the 0. I'm doing 5 to the 0 times 4. This is the only thing that's being raised to the 0 power, so that is equal to 1. But I still have to multiply this expression by 4, which makes this answer 4. Okay, so the only thing that's 1 is the only thing that's being raised to the 0 power. If there's something else next to it, you have to account for that. Okay, and then negative exponents, very similar. So number 7, that's the same since the coefficient is 1. It's the same as doing 1 over 3 squared. Okay, and you can kind of figure out number 8 from there. And then the only thing other one I want to talk about is something like number 9. So number 9, my coefficient is not 1 this time, it's 5. So that actually stays on the top of my fraction because that doesn't have a 0 or a negative power. So the only thing I'm actually moving to my bottom of my fraction is x to the 4th. So that would be how I simplify an expression like that. So kind of use those examples as you're working through the practice to complete this practice. And then if you have any questions, make sure to ask your teacher.